we're all talking about generative AI at the moment, and I see that generative AI is a great way to democratize access to some of the other flavors of AI that we've been working on and using for a long time. So, in a retailer, one of the things that we really think a lot about is how much of our products can we sell tomorrow, next week, next year. And therefore, one of the big use cases that we've had for a number of years now is that demand forecasting. It's quite simple for one product to be able to say, well, I think I could sell 10 tomorrow and 20 next week and so on and so forth. But how do you do that across tens of thousands of products across hundreds of stores? That's where those problems start to become quite challenging, especially when you don't know what the weather's going to do, you don't know how customer behavior is going to change.
Welcome to Data and AI Mastery, the podcast where we bring you cutting-edge insights, practical advice, and inspiring stories from the leaders shaping the future of data and AI across the globe. I'm your host, Raoul-Gabriel Urma, founder of Cambridge Spark, the leader in transformational data and AI upskilling, career development, and progression. In each episode, I will be diving into real-world case studies of companies harnessing the power of AI to drive innovation, reduce costs, and create new business opportunities. So whether you are an aspiring data scientist, AI engineer, or seasoned executive, this show is designed to give you the tools and knowledge to stay ahead in a world where data is transforming every aspect of business. Stay ahead, stay inspired, stay masterful. Welcome to Data and AI Mastery.
All right. Hey, Peter, how's it going?
Yeah, very good. Thank you. Nice to be here. Nice to have a chat today. Looking forward to our conversation.
I'd like to start by talking about you and your background and what led you to where you are today. So, Peter, for the listeners, what sparked your interest in the data and analytics space, and how did your passion lead to where you are today at Morrisons?
I think growing up, I was always more interested in numbers than people. I remember sort of as a child, I talk quite a lot about this when I do presentations, but I was given a very basic old computer. It was a Sharp machine, and it had a huge amount of memory. It had about 48 kilobytes. But I remember getting that machine and thinking how I could use it to kind of jot down things that were happening around me. So like, what I was eating, what I was doing, where I'd been on my bike, and things that you look back now and slightly cringe, but actually it was all very much early days sort of data collection, data processing. And I've been doing that since I was 7, and that's a very long time ago. And so I think, as I've got older and went through education, sort of did a lot in mathematics and became fascinated by how things work from a conceptual perspective. So throughout my career, I've always found ways to kind of bring numbers and data and modeling and kind of strategy into one place. So I think if you were to speak to my family members, it's probably no surprise I am where I am today, because it was always just something that numbers, data, patterns, insight was just who I was from a very, very early age.
That makes a lot of sense. And do you think an appreciation for numbers, maths, is important to develop a career in the data industry?
I think curiosity is really important. Whether you have to be, a degree level mathematician or not, I think different people have different skills, don't they? But I think one of those inherent characteristics has to be a curiosity. To work in data, you have to be interested in finding new ways to explore the things around you, because that's a very fundamental part of the job. So the mathematical side helps, and physicists, engineers, they're all kind of have similar training, similar thought processes, but it's curiosity. I think that's the most important trait, really.
Great. Yeah, that resonates a lot. So kind of understanding what's going on and why, and questioning it, those are kind of like the attributes you're describing. And I'd like to understand a bit more about your sort of pathway to become the director of data analytics at Morrisons. In particular, was there any sort of challenges throughout your career to get where you are today, and what did that look like?
I think there's always challenges, aren't there? I mean, nothing's ever straightforward. I think the biggest thing I've tried to work on is being clear on my personal purpose. So what is it that I can bring that's different to other people? And what is it that the teams I'm leading, what do we need to do differently in order to to kind of fit the space that we've got at the time. The thing about being in an industry that's innovating so rapidly is that A, no one's got the answer, and B, most of the people you're working with are similarly grappling with what the right answer is. So it's not just that there are one or two solutions or one or two potential options that are in front of you. It genuinely are so many things you could try. It's how do you find the right path through that? So there's clearly been a lot of challenges along the way. I think my own reflection on my career is I've tried to bridge that gap between, I'm not the world's best data scientist. I'm not the world's best mathematician. I'm certainly not the world's best general manager. Where I've tried to find my scope, if you like, is trying to be good enough at those three things that I can add some value to the organizations that I'm working for. I was lucky enough to do a period of consulting. So before Morrisons, I spent 10 years working in the advertising industry, working for an agency. So I got to work with a large number of organizations on some really interesting projects, and that really helped kind of hone the softer skills, if you like. It meant that I was able to refine my own thinking in terms of how you land a project. I saw a really interesting stat the other day that said that for every pound you spend on a tech implementation, you probably need to think about spending £5 on the change that goes around it. Whether you agree with those numbers or not, I think the sentiment is the right one. Is that actually, as a leader in this field, it's more about how we work with people to drive the innovation and land the change as it is about the technical side of things. So I think the biggest challenge in my career getting where I have today is being really balancing those two things. So being technical enough to understand what we're trying to do, but being a broad enough manager that I understand the context of the business and the problems we're solving, so that we can kind of bring the two together.
Yeah, that really resonates. So it sounds like it's all about the people, both internally to drive change, but externally your customers, and work with them. It sounds like your career in consulting has really helped with building those aspects. Great. So look, since we're talking about AI, I'd love to deep dive a bit more in some of the use cases that you've been working on. And of course, AI has been around for a long time. It's obviously now it's in every news article, specifically generative AI, but you've been working at Morrison on those sort of use cases that can leverage AI way before the hype, within supply chain, predictable maintenance, and so on. So I'd love to understand from you, can you give us a broad overview of some of the use cases that you get excited about at Morrisons?
Absolutely. I think the thing we have to remember is AI goes in hype cycles. So, if you go back to the academic literature, I think AI as a concept was kind of almost done and dusted in the late 90s, early 2000s in terms of some of the fundamental bits of kind of maths and computing that were needed. And it's really interesting to sort of see that come round in circles as a number of things come together in terms of the power of the compute, the ability to work in the cloud. All these things sort of come together to mean that we can then leverage the potential. So we're all talking about generative AI at the moment, and I see that generative AI is a great way to democratize access to some of the other flavors of AI that we've been working on and using for a long time. So, in a retailer, one of the things that we really think a lot about is how much of our products can we sell tomorrow, next week, next year. And therefore, one of the big use cases that we've had for a number of years now is that demand forecasting, where we can, it's quite simple for one product to be able to say, well, I think I could sell 10 tomorrow and 20 next week and so on and so forth. But how do you do that across thousands, tens of thousands of products across hundreds of stores? That's where those problems start to become quite challenging, especially when you don't know what the weather's going to do. You don't know how customer behavior is going to change. There are some really interesting examples where there are specific products that if they're shown on TV programs, probably can't mention specific ones, but some of the reality TV programs where a particular contestant or featured individual might bake with a particular product or might drink a particular drink, or whatever that is, that can have a significant impact on the demand for a particular product. So there's a number of layers in that forecasting problem that are fascinating, because doing it in isolation from the past is hard enough. Predicting the future in an uncertain world where we might have major storms next week, or we might have a heat wave in 3 months. There has to be a level of realism that we bring to that particular problem. So it's fascinating in a real sale context, because we don't need to get the answer perfect. We need a direction of travel, and it needs to be as good as possible. And therefore, not only are you trying to shape the best solution you can get, but you're also trying to interpolate the answer you get from the AI into something that you can use within a business to actually operate various functions within your business. So that demand supply chain optimization piece is really at the heart of most retail businesses these days, and being able to do that efficiently and without any major technical problems, it's hard yards. And where I think things are becoming really exciting is that you had to be a trained data scientist, or you had to be somebody with a head for numbers, or an understanding of some fairly complex bits of technology in order to ask some fairly tricky kind of what if or why type questions of that forecast. Where I see there's some really interesting work coming now is that in that world of generative AI, it's given us a layer of democratization that means that we can start to ask some better questions of our traditional AI tools. So, even if you took a robot, and we have a number of robots that work across our manufacturing business, for example, we have a great piece of robotic kit that can take pita breads off a production line and pack them for us. And really, it's a set of cameras that are looking at where things are in physical space, and then it's working out where the arm needs to be at a point in time in order to pick it up. What happens if that process goes a bit astray? Typically, it doesn't. But again, you would have to have employed a robotics engineer in the past to really understand how to optimize that. Generative AI may give us ways that we can ask questions of those kind of systems without the level of technical training that might have been once needed.
I'd like to deep dive a little bit in that sort of supply chain optimization world. Could you at a high level talk about, the business impact of getting the forecasting right? Can you talk through at what point is diminishing return in, or is there diminishing return in, trying to make your forecast more and more intelligent? Could you talk through a little bit about those trade-offs?
Yeah, I mean, the ability to predict the future is really important. Certainly in fresh food retail, the big dynamic we have is some products might only have 3 or 4 days shelf life on. So, cheese is a great one. Cheese has got, anything up to 70 days life on it. So we can order, and keep it on the shelf in the shop. And we're not going to generate a huge amount of food waste if we get that order wrong. But there are other products that will need to be thrown away within a few days if we can't sell the stock. So it's as much a way of optimizing the operations in our business as it is a sustainability point in terms of reducing the amount of food waste that food that's produced unnecessarily, or that we're creating unnecessary landfill or what have you. There's a real benefit in getting it right, because I'm sure we certainly in the UK we'll all be familiar with that first weekend in May where we're wondering whether we can crack out the barbecue or not, and is it safe to invite our friends round, and will we have the weather? There's a point in the year where we're not quite sure how many burgers or hot dogs or what have you that we might sell, because if the weather's fantastic, then we'll sell loads. If we get it wrong and the weather isn't there and no one wants to barbecue, then we might be left with a lot to throw away. So it's really important that we get that right. Your point about diminishing returns, the benefits are such that there will always be a diminishing return, because there always is on any kind of optimization. But I don't think we're there yet with it, in terms of there is still things that we can improve on, and I still think it's worth our effort. The other interesting point in this space is, the algorithms, don't let me cheapen the algorithm for a second, because, there's a lot of great work that goes into tuning those algorithms and making them continue to learn and evolve and keep pace and make sure that we're not drifting in terms of models. But a large amount of the effort has to be the input data that goes in the first place. And therefore, can you get a better weather model? Can you get a better other model that might help us with a bit more insight in terms of what customers might do? So there's always going to be things that you can do to improve, and I don't think we're quite at the point of diminishing returns yet. There's still a huge amount of interesting problems to solve and opportunities to make things even better.
That's a really interesting point you made that I think is often overlooked. So you said that, if we can get better data input into the model, like the weather, for example, forecast, then your output will become better. maybe irrespective of how much effort you put in the model itself. So how do you navigate that trade-off between, let's invest more in maybe in the modeling, your algorithm, versus let's invest more in the data quality or the data input? I guess the question is more overall is what does it take to build a system like that for it to work, and what would you prioritize to like get good results?
I think the key is to be clear on the whole system that you're optimizing for. So it's really important that we have components, and you try and make all those components as good as possible. But really, our job is to look at the outputs that we're creating and the value that those outputs are generating. So in answer to your question, you know when to start and stop and how much to change things. If fundamentally the forecast isn't anywhere near what actually happened in reality, we've got to find out why, and we've got to invest in making it better. Now that might be the model layer itself, and you could look at all the sort of traditional tools that we have to see whether the model is predictive and whether we've overfitted and all of that sort of stuff. But typically that's where we start. Once you realize that you're exhausting your possibilities or your potential to change anything, it tends to tell you that the data that goes into those models might need a bit of a might need to be observed in some way. So I think the key thing is not to be narrowly viewing it as one thing or another. It's not do we improve the data that goes in, or do we improve the model? It's what is my system generating for us, and do we think that that was a reasonable prediction? And the other thing to bear in mind as well is I've had a number of requests over my career to try and model things that were just inherently unmodelable. And as much as you might think that a computer should be capable of learning what might happen in the next hour or the next few hours based on the past 6 hours, just as an example, sometimes there are scenarios and systems where you go, inherently it's random, it's a stochastic process, and therefore I can give you an estimate, but actually we might have to just accept that this isn't something that we can model within an inch of its life. So a plus or minus 5% might be as good as you can get. So I think more broadly what I'm trying to say is that it's having that real world understanding of the processes that you're building, and a kindness to yourself and the team that's developing it to go, actually, can you make it better? Or do we just have to accept that, a reasonable answer is good enough in this situation because it's better than what we've already got? So I think it's a great question that you've asked. I'm not sure there is one precise answer to it, other than being really, really clear on, has the thing we've built done the job we wanted it to, and being really curious and quite challenging of ourselves to go, can we make it better? But recognizing that sometimes you can't.
Thank you. That's a really interesting answer. It sounds like you have to be pragmatic. You need to have some measure of it's good enough success to just guide you.
So one thing I would, the world that you live in is partly driven by teaching others, isn't it, in terms of how to do some of these sort of fundamental techniques. And I think what I found really interesting is watching the learners from my team who have been on your courses. Often the questions they're asking me are, there was one on linear regression recently where they were interested in the trade-offs between quite where you put the line, in very, very basic terms. And I think what I would always want to get across to learners and people who are interested in the field is that you've got to understand the academic basis for why these things work, and the mathematical models that go into the rationale behind why these techniques are sound and why they're not. But then there's an art form in terms of deploying them in the real world in industry to get them to work. I remember in the early days of my career, I gave my boss, who was he was a CEO of a business. He'd been a really senior exec at Coke for a number of years. And I remember walking into him with all my sort of handwritten notes on the linear regression process I'd done for him. And I remember trying to to him that the coefficients I'd chosen were fine. And he just looked at me and it was, I couldn't have offended him more if I'd have, drawn pictures of his children and thrown darts at them. It was, it was
like a fun conversation.
Defining moment in my career. And then I realized that actually my job is that he trusted that I knew what I was doing, and that my job was to then take everything I'd learned about how to do it properly and then to adjust it into the real world, to make those real world adjustments that were needed for us to use it effectively. Because at the end of the day, when we're dealing with real data that comes from humans who are behaving in inherently in unpredictable ways, there's going to be a level of noise that we're going to have to deal with. And therefore, there's an art form in applying what's effectively a hard science in the real world.
Well, I'm glad you're taking us into the real world, because I really wanted to touch on that, because fundamentally there's different things you need to deploy those model in real world system to make it work at a business level for Morrisons. And I know in one of your recent posts, you've highlighted you need strong data infrastructure, strong data foundation, but also kind of like engineering skill set to be able to build, deploy, maintain a system. Could you talk through a little bit how you view, the gap between we can get excited about linear regression, the coefficients and modeling, versus we have to actually ship a solution in the real world? What do you need to make that happen? What are the sort of the key components for success in your eyes?
So, if I'm doing work on my house, I might invite a builder around to look at a kitchen, and we might talk about rebuilding the kitchen and doing some great things. The builder that's going to get my work is going to be the builder that can talk to me about, let's move the island, let's put the island in the center. You're going to be able to cook as a family. You're going to be able to share this amazing food. You're going to create an emotional connection. At no point when that builder comes into my house am I asking him to explain to me when you use a hammer and when you use a circular saw, because I'm trusting that actually the fact he's a master builder and he can show me these great pictures that have amazing kitchens that he's installed over the years. I sort of trust he can do all of that. And I think so that there's a level of hygiene that's needed in all of these roles, which is that we have to be able to understand conceptually which method is going to work when and which method might be a bit dodgy. In the same way that, the builder will use a circular saw to get a really nice cut on a piece of wood, but he's then going to use a hammer to knock a nail into the wall. He needs to understand that you can't use the hammer to knock the wood out to cut the shape that you need for the worktop. And then for sort of back to this sort of pragmatism in the workplace, is that we've all got to show up being able to use the tools that we're given. And we've also got to be capable to know when we need a better tool. So when to be curious enough, when to be not satisfied enough that the tools we've currently got are doing the best job. So as the builder gets more experience, they might invest in better and better equipment in order that they can do an even better job. So, we need our teams and our colleagues to kind of go on that same journey. But in the real world, we're solving real world problems. And therefore, there might be a situation where tool A or tool B broadly are going to give a similar result. And therefore, there'll be other criteria, other constraints that we need to think about. And therefore, I'm a big believer in, yes, it's really important to understand the academic basis. And it is actually really, really important, because the number of times I've seen people use the wrong method, so use the wrong library in scikit-learn or whatever it might be, because they don't quite understand that wasn't the right choice for this reason. Is your data normally distributed or is it not? And that tends to be where novices can go wrong quite quickly. But the way I try to coach my teams is to really help them understand that actually the job is to bring the art to the science, and mean that when we're finished and we've made all these really scientific choices along the way to use the right tools in the right way, that actually the thing we did delighted the customer and gave them something better than they were expecting. So in my day-to-day world, that might be some analysis that highlights some patterns that we weren't expecting to find, or we didn't think were going to be there, that might help us understand what we need to do to help delight our customer in a particular category, or find ways of optimizing a particular process or what have you. So really we have to focus on that being the job, not the use of the tool in the first place. The tool is the hygiene